Dear students, welcome to today's class. I hope that you are all wrote today's examinations very well. Okay. So, for your preparation for tomorrow's examination, I am going to explain few more problems which are very important model for you. So, just to practice these type of problems and to see how the solutions are going on, what are the tips and tricks to solve the problems. Okay, there are certain problems are there, so you no need to solve the complete problem. So, just by graphical methods also you can solve the problem. So, such type of problems also I am going to explain today's class. Okay, so let us start our class. So, dear students, coming to the first problem of today's session, the first problem is let f of x is equal to modulus of x minus 1. Then points where f of x is not differentiable. So, therefore, this function is not differentiable at what points. So, if you observe the concept, so the function is not differentiable when the function has a sharp edges. For example, so there is a x-axis and a y-axis. There is a curve is like this it is a curve. At the sharp edges, and for example, here it is a one sharp edge is there, here it is one sharp edge is there, here one sharp edge is there. At the sharp edges, a function is not differentiable. Understand? At these sharp edges, a function is not differentiable. Okay now, right. Why? Because at this point there exist infinite number of tangents. Okay. Further, at the sharp edge points, the function is not differentiable. Now coming to the given problem, so here the problem is y is equal to modulus of x minus 1. Try to draw the graph for this problem. Okay now, right. So if you draw the graph, to draw this graph, there are three steps are there. First one, the first graph is draw the graph of y is equal to modulus of x. The second one is draw the graph of y is equal to modulus of minus 1. And the third graph is y is equal to modulus of x minus 1. So like that, you have to draw the three graphs. The first graph is modulus of x graph. The second graph is modulus of minus and 1. That means not three graphs all together in one graph you have to show. Then how to draw this graph? So all of you look at the board. First, y is equal to mod x graph. Y is equal to mod x graph. Everybody we know this is a x-axis and it is y-axis, x-axis and y-axis. This is a y is equal to modulus of x graph. This is the first graph. Okay now, coming to the second graph is this. What is the second graph? Y is equal to modulus of x minus 1 means what? Total this graph comes down 1 unit, That means then your graph will be like this. So this is x-axis and y-axis, this is. So this will be your y is equal to modulus of x minus 1. So this is minus 1. So total graph will come down, same graph will come down to 1 unit. So this is a modulus of x. Now coming to this modulus of x minus 1 graph. So here there won't be any negative value. Why? Because modulus, we are putting modulus means what? Y takes only either 0 or positive values. So whatever may be the graph come the below of the x-axis, you have to take its reflection. That means what? What is the reflection of this? So this is the graph of. Now it won't be there now. So if you observe, so this is observe. This is the graph of y is equal to modulus of x minus 1. So this will be the graph. Understand? So this is equal to 1, this is -1, this is 0. If you observe where you are getting sharp edges, at -1, at 0, at 1, that is equal to 0 comma plus or minus 1. You are getting the sharp edges at 0 comma plus or minus 1. At that point, the function is not differentiable. Therefore, your answer is A. Understand, my dear students? So, this problem will be done using a graph of the given function. Very, very easy problem. So, in JEE mains also, you can solve some problems using graphs like this. Okay. So, I hope that you understand this solution. So, let us go for next problem. Dear students, welcome to second problem. An infinite geometric progression has first term x and sum to infinity as 5, then x belongs to. So, here it is given an interval, x belongs to which of the following interval, he is saying. Okay now, right. If you observe, here it is given infinite geometric progression. Infinite geometric progression. What is infinite geometric progression? Here AR square, so on, infinity. It becomes an infinite geometric progression when its common ratio, that is, the common ratio is denoted by R. The modulus of R is less than 1. That is, R value lies between 1. If the R value lies between -1 to 1, if R value lies between -1 to 1, that is a common ratio, then the whole sum is converged into a finite value. Okay, now converges to a finite value. Okay. So, the condition is here is modulus of R is less than 1. So, coming to the problem here, it is given that the first term A is x, sum to infinity, S infinity is equal to 5. What is S infinity formula? A by 1 minus R is equal to 5. Sum to infinity formula. Here A value is given, x by 1 minus R is equal to 5. Okay now, right. So, from this we can say that 1 minus R is equal to x by 5. So, this implies R is equal to how much? 1 minus x by 5. Okay. Now, we know the condition R lies between -1 to 1. Therefore, what is the R value? 1 minus x upon 5, that is equal to -1 less than 1 minus x by 5 less than 1. So, from this try to find out the value of x. So, for this I will write down here 1 minus line 5 minus x by 5 less than 1. So, multiply with 5. So, this is a minus 5 less than 5 minus x less than 5. Okay. Subtract 5 minus 5. This is equal to minus 10 less than minus x. If you subtract here, you will get 0. So, here minus x is there, make it into positive. So, that is why multiply with minus 1 throughout the equation. At that time, the inequality signs will be changed. So, this is 10 greater than x greater than 0. Therefore, 0x, 0 less than x less than 10. Okay now. So, if you observe, the option C is the right answer. So, such type of problems are also giving in the JEE mains examination. Such a very, very easy one. The only thing you have to remember is in an infinite geometric progression, the R value strictly lies between -1 to 1, and the sum to infinite formula is A upon 1 minus R. If you know these two concepts, the problem is very, very easy. I hope that you understand this solution. Let us go to third problem. Dear students, welcome to third problem. The number of integers greater than 6000 that can be formed using the digits 3, 5, 6, 7 and 8 without repetition. Okay. So, this was asked in 2017 JEE mains examination, 2017. Right, here what are the digits you have to use? 3, 5, 6, 7, 8 you have to use. 5 digits are given. you have to form a numbers which are greater than 6000. 6000 is a 4-digit number, so there is a possibilities of numbers, 4-digit numbers are also which are greater than 6000. Why? Because here 6 is there, 7 is there, 8 is also there. Obviously, all 5-digit numbers are greater than 6000. Okay, now, so first I will take the case 1 as 4-digit numbers. 4-digit numbers. So here take the 4-digit numbers 1, 2, 3, 4. So this 4-digit number, here you come to this thousands place. In the thousand place, you can put 6 or 7 or 8. That means 6000. Here if you keep 3 or at least if you put 3, 6300, it is greater than 6000. Okay, now, right. This box can be filled in how many ways? 3 ways. This box is filled in how many ways? 3 ways. Now coming to here, so after filling this 6 or 7 or 8, 3 numbers, out of this 5, one number is filled here. This box can be filled in 4 ways. Since the number should be without repetition, you should not repeat. And this box can be filled in how many ways? 3 ways. And this box can be filled in how many ways? 1 way. Therefore, total number of numbers, 4-digit numbers, which are greater than 6000 means how much? So this is 3 into 4 into 3. So 3 4s are 12. So this is 3 into 4 into, so this can be done in 2 ways. So this is equal to into 2, this is equal to 72 ways. Okay, now, right. Now coming to case 2. Case 2. All 5-digit numbers. All 5-digit numbers. So how many 5-digit numbers will be there? 5 factorial, 5c, 5 factorial. Sorry, 5p, 5. So this is equal to 5 factorial. All 5-digit numbers are greater than 6000. Why? 6000 is a 4-digit number and all 5-digit numbers will be greater than 6000. So this is 5a factorial. This is equal to 120. Therefore, total number of numbers is equal to how many? So this is 4-digit numbers are 72 and 5-digit numbers are 120. Total 192. So therefore, option B is the right answer. Such type of problems are also giving in JEE mains examination. Okay, na? So very easy problem and a very easy solution. Okay, I hope that you understand this solution. So let us go for 4th problem. Dear students, welcome to 5th problem. The 5th problem is from matrices. The 5th problem is if A is equal to the matrix A 1 2 2 2 1 minus 2, second row, third row A 2 B is a matrix satisfying the condition A into A transpose is equal to 9i, where I is a 3 by 3 matrix. Then the ordered pair A comma B is equal to. Such an easy problem is giving in the JEE mains examination. Here A into A transpose is equal to 9i. That is, what is A? 1 2 2 2 1 minus 2 A 2 B into divided by what is A transpose? What the transpose? First row becomes first column, second row becomes second column, third row becomes third column, A 2 B times this is equal to 9i, that is 900 090 009. That's all. Such a easy problems are also giving in the JEE mains examination. Now what you will do? So we have to find out the A and B value. So here only don't try to completely do the problem. So why? Because first you don't multiply this. So first row by first column you will get 9. Why? Because we want equations from A and B. Don't multiply that. First row, second column also don't multiply. Yes. First row, third column multiply. A into 1 A plus 2 into 2 4 plus 2 into B 2B. This is equal to how much you will get here? 0 you will get. So this is equal to A plus 2B is equal to minus 4. a plus 2b is equal to minus 4. So, only this equation is enough to check the problem. Why? Because here all options are different, So, if you observe, substitute these values, if you observe how to get minus 4, see option D you check, option D is equal to how much? Option D is minus 2 minus 1. In place of A, substitute minus 2, in place of B, substitute minus 1. Minus 2 minus 4 is equal to minus 1. Therefore, option D is right answer. So, if you check something more, you can do like this also. This is a third row with the first column. You multiply A times 1A plus 2 2s are 4 plus 2B is equal to 0. So, this is also you are getting A plus 2B is equal to minus 4. Understand? So, in both the cases you are getting the same answer. Therefore, your option D is the correct answer. Okay. So, I hope that you understand this solution. Let us go for next problem. Dear students, welcome to the fifth problem. The fifth problem is this. For a positive integer n, if the quadratic equation x times x plus 1 plus x plus 1 into x plus 2 plus so on, x plus n minus 1 times x plus 1 is equal to 10n has two consecutive integral solutions, then n is equal to. This quadratic equation has two consecutive integral solutions. That means what? What are meant by consecutive integral solutions? 2, 3, 5, 6. This side minus 2, minus 3, minus 4, minus 5. These side by side numbers, consecutive integral solution. What do you observe? Their difference is 1. That means 2, 3, difference is 1. 5, 6, difference is 1. Minus 2, minus 3, difference is 1. So, that means whenever you have a quadratic equation ax square plus bx plus c is equal to 0, it will have two roots alpha beta. It has two roots alpha and beta. If it has two consecutive integral solutions, their difference is equal to 1. Difference, why I am keeping modulus means we don't know which is greater, So, 5 6 or 6 5. The difference is 1 only. That is why modulus of r minus 1 alpha minus beta is equal to 1. So, if you know that concept, the problem will be very, very easy. Okay, now, first given one equation is there, but it is not in the standard form. Let us convert into standard form. So, if you observe, so first you multiply x into x, x square. So, here also you will get x into x, x square. Here also you will get x into x, x square. Such a type of x squares, how many you will get? So, here 1x square you will get, second expressions 1x square you will get. Like that, how many terms will be there? N terms are there. You will get nx square. Therefore, x square plus x square plus x square. How many x squares are there? Nx squares are there. Nx square plus. Observe here constant x into 1. 1x here 2x plus x, 3x. Here 1x, here 3x. Next you will get 5x. Next you will get 7x. Ultimately, lastly, how much you will get? 2n minus 1x, odd numbers. That is equal to 1 plus 3 plus 5 plus so on 2n minus 1 into x plus. Coming to the constant terms, here you won't get any constant term. Here if you observe the constant term 1 into 2 constant. Here next term 2 into 3, next term 3 into 4, such that last term n minus 1 into n, that is equal to 10n. Understand? If you observe, this is a nx square only. Now, up to here, what is the value? This value is how much? If you observe, these are nothing but the sum of the first n odd natural numbers. For that, there is a direct formula is there, that is equal to n square x. Understand? Coming to here, what is this sum? right? You will get this some formulas in progression chapter, series and progressions. You will get this type of. Sir, what is the nth term here? What is the nth term? Tn is equal to n minus 1 times n. This is the nth term. So that is equal to Sn, we have sigma Tn. That is equal to sigma Tn means what? N square minus n. So this is sigma n square minus sigma n. Sigma n square formula n into n plus 1 times 2n plus 1 upon 6 minus sigma n formula n times n plus 1 upon 2. Okay now. So if you take it common outside, you will get n times n square minus 1 upon 3. So this total value is n times n square minus 1 upon 3. So this is minus 10n is there. Take it to left side, that is minus 10n. Okay now. So here you observe here n square, n. You can divide with n since n is not equal to 0. So this is x square plus nx plus n square minus 1 by 3 minus 10n is equal to 0. So here n is also getting cancelled. So afterwards you multiply with 3. So this is equal to 3x square plus 3nx plus this is n square minus 1. This is minus 10 minus 31 is equal to 0. So this is your quadratic equation. Ax square plus bx plus c is equal to 0. Okay. So it has two roots, that is alpha and beta. So that is modulus of alpha beta is modulus of alpha minus beta is equal to 1. From that we will get the value of n. Okay na? So let us continue our solution. So dear students, welcome to the solution. So it is given that already it has two consecutive solutions, two consecutive integral solutions. Let that be alpha and beta. We have modulus of alpha minus beta is equal to 1. So what is modulus of alpha minus beta formula? We have under square root of b square minus 4ac by modulus of a is equal to 1. Okay. So what is a value? 3. What is b value? 3n. What is c value? N square minus 31. So substitute here under square root of b square. B square means 9n square minus 4a means 3. C means how much? N square minus 31 upon modulus of 3 is equal to 1. So if you solve these equation, so no need to solve equation, verify the option verification. Let us take option D. Option D is equal to n is equal to 11. You substitute here wherever n is there, you substitute n is equal to 11. Here also n is equal to 11. You substitute and you simplify that. You will get left hand side is equal to right hand side. Okay. So it is such an easy problem. So here no, don't try to solve this complete problem. You can do the option verification. So therefore for n is equal to 11, this quadratic equation will have a consecutive integral solutions. Okay. I hope that you understand this solution. So let us go for sixth problem. Dear students, welcome to the problem number 6. If f of x is the integral of 2 sin x minus sin 2x by x cube, where x is not equal to 0, we have to find out limit x tends to 0, f dash of x is f dash of x. This is a problem both from limits and integral. So first thing, what is given? F of x is the integral of 2 sin x minus sin 2x by upon x cube dx. F of x is the integral of 2 sin x minus sin 2x upon x cube dx. Okay now. So how to get f of x? As already we know, integration is the reverse process of differentiation. So just you differentiate with respect to x on both sides, you will get f dash of x is equal to 2 sin x minus sin 2x by upon x cube. Okay now, we got f dash of x. Apply limits on both sides. So limit x tends to 0, f dash of x is equal to limit x tends to 0, 2 sin x minus sin 2x. Can I write down 2 sin x cos x upon x cube? Okay now, right. Okay, so this is equal to limit x tends to 0. 2 sin x you can common outside, 1 minus, this is equal to cos x by x cube. This is here, you put x square here. X cube I am writing x and x square. Why I am writing here means, here sin x by x, limit x tends to 0, sin x by x value is equal to how much? 1. So this will become, so this is equal to, so 2 times limit x tends to 0. 1 minus cos x means 2 sin square x by 2 upon x square. This is equal to 2 2s are 4 into 2 2s are 4 into. So this is equal to 1 by 2 whole square. So that is sin square x by 2 by x square value is, x coefficient is how much? Here also square is there, here also square is there. Therefore, what is the x coefficient? 1 by 2. 1 by 2 square will come. So this is equal to 4. 4 is also gets cancelled. So 1 is your answer. So your option C is the correct answer. Such a easy problems are giving. The only thing concept is here, f of x is the integral of one given function. So how to remove this integral means differentiating. So why? Because integration is the reverse process of differentiation. Okay now, I hope that you understand this solution. Okay, so let us go for next problem. Dear students, welcome to the problem number 7. It is the integral of 2 to 4 log of x square upon log x square plus log of 36 minus 12x plus x square dx is equal to. So this comes under definite integration. So to solve this problem, whenever it is there, integral a to b is there, we have a very interesting property. So that is integral of a to b f of x dx is equal to integral a to b f of a plus b minus x dx. That means add a plus b, f of a plus b minus x dx. So let us take this problem as call it as I, that is integral 2 to 4 log over x log of x square over plus log of, if you observe here, 36 minus 12x plus x square, it is a perfect square. It is a perfect square. You can write it as a 6 minus x whole square dx. Is it right? A square 36 minus 2ab minus 12x plus b square x square. Okay now. So you call it as 1. Right. Coming to here, now I am going to apply this property here. What is that property? Integral a to b f of x dx is same as integral a to b f of a plus b minus x dx. A plus b means both you have to add. That is 2 plus 4 is equal to how much? 6. So this is same as 2. So log of, this is 2 plus 4 is equal to how much? 6. This is 6 minus x whole square by log of, in place of x, what you will write down? 6 minus x whole square plus log over 6 minus of, in place of x, what you have to write down? A plus b minus x. That is 2 plus 4, 6 minus x. 6 minus x whole square dx. So I will simplify this. So this is equal to I is equal to integral 2 to the power 2 to 4 6 minus x whole square upon log of 6 minus x whole square plus log of. So here plus 6 minus 6 cancel, minus of minus plus, this is equal to log x square dx, call it as 2. Right. So such type of problems you will do so many things. So if you observe adding 1 and 2, if you observe that, so denominator, so limits are upper limit and lower limit are both are same, 2 to 4, here also 2 to 4. Observe the denominator, this is log x square plus log of 6 minus x square. This also log x square plus log of 6 minus x square. See the observe log x square plus log of 6 minus x square, both will get cancelled. So you will get, so 2I is equal to integral 2 to the power of 4 1 dx, both will get cancelled. This type of problems you are doing many type of problems. So this is equal to 2I is equal to x into upper limit 4 lower limit 2. So this is a 4 minus 2, 2. Therefore, I is equal to 1. So therefore, option C is the right answer. The only thing is, so if first thing is, you have to get an idea, this can be written as 6 minus x whole square. After that, you have to get this property. If you know that property, the problem is very easy. So this was asked in 2015 JEE mains examination. Okay, I hope that you understand this solution. So let us go for next problem. Dear students, welcome to 8th problem. So it is comes under application of differentiation. Okay, now right. A 20 meters of wire is available for fencing off a flower bed in the form of a circular sector. Then the maximum area of the flower bed is. Okay, na? Right. First of all, there is a wire of 20 meters. There is a wire of 20 meters. Then it was converted into a circular sector. Circular sector means this type of this. Right. So total length is 20 meters. Then what will be the maximum area of that circular bed? Okay. So let it be theta. Let the radius of the sector is r. What is the length of the arc? We have L is equal to r theta. This is r theta. This length is equal to r theta. Length of the arc is equal to L is equal to r theta. So from this data, what we have, r plus r theta is equal to 20. That means the total length. So this plus this r plus r theta plus r is equal to 20. So from this 2r plus r theta is equal to 20. From theta is equal to 20 minus 2r by r. Put it like that. Theta is equal to how much? 20 minus 2r by r. Right. What is the area of the sector? What is the total area of the sector? We have formula 1 upon r square theta. 1 upon r square theta. This is also the one of the formula. That is A is equal to 1 upon r square. Theta means 20 minus 2r upon r. Okay, na? Right. So one r will get cancelled. From this 2 is also get cancelled. You will get r times 10 minus r. Okay, now. So this is equal to 10r minus r square. Okay. 10 minus r square, 10r minus r square, right. So this is your expression. This should be maximized. For a maxima or minima, the first derivative should be equal to 0. What is the first derivative? dA by dr. That means differentiating with respect to r on both sides. So 10r derivative is 10 minus r square derivative is 2r. So for maxima minima, we will get dA by dr is equal to 0. So this implies 10 minus 2r is equal to 0. From this, r is equal to 5. When r is equal to 5, so the area of the sector may be maximum, may be minimum. So how to decide that? So to do the second derivative test. What is the second derivative of this? d square a by dr square, that is equal to minus 2. For the 10 derivative is 0, minus 2r minus 2, it is a less than 0. So less than 0 means that expression a will have a maximum value when r is equal to 5. Therefore, what is the area of the sector? What is the area of the sector? Half into r square. R square means r square only. Theta value, write down this. Theta value, write down this. That is 20 minus 2r by r. Okay, now. So half r square theta. Okay, now. So that is equal to, already it is 10r minus, we will simplify that, 10r minus r square. That is 10 into 5 minus r square means 5 square. That is equal to 50 minus 25. That is equal to 25. So option C is the right answer. So very, very easy problem. So if you know this answer, First thing you have to know is the length of the arc is L is equal to r theta. The second thing what you have to know is area of the sector is half r square theta. So if you know these two formulas, the solution is very easy. Okay, I hope that you understand this solution. So let us go for ninth problem. So dear students, welcome to ninth problem of this today's class. So the problem is if x, the set x is equal to 4 power n minus 3n minus 1 where n is a natural number. It is given in set builder form. Like that, the set y is also given as 9 times n minus 1 where n belongs to n. Both sets are given in set builder forms where n is a natural number, set of natural numbers. Then, so where n is the set of natural numbers, then x union y is equal to, right. So first they are given in set builder form. Let us convert it into roster form. Okay na? So here x is equal to, if you observe here 4 power n minus 3n minus 1, first substitute n is equal to 1. What are the natural numbers? No, first substitute n is equal to 1. So here 4 power 1, 4 minus 3 minus 1, you are getting 0. Okay now. So if you substitute n is equal to 1, over n is equal to 2, that is 4 square, 16 minus 6 minus 1, n is equal to 2 if you substitute. So 16 minus 6 is equal to 10, 10 minus 1, 9. If you substitute n is equal to 3, if you get that, you will get 54, next to 243, so on. Okay now. Coming to y value, right. Substitute first n is equal to 1, n is equal to 1, substitute first natural number is equal to how much? 0. Next n is equal to 1 over, n is equal to 2. 2 minus 1, 1, that is equal to 9. N is equal to 3, 3 minus 1, 2, 2s are 18. So like this 18, so on 27, so on. Okay now. So clearly if you observe, x is the subset of y. X is subset of y. So that is x is, this is a x set is subset of y. Then what will be x union y? X union y is equal to how much? Y. So that your x union y value is equal to how much? Y. Understand? Understand. So very easy one. Clearly x is subset of y. X is subset of y because here you are getting 9 and 54 also. You will, next number is 54 only. Next number is 54 only. You will get 9 table you are getting. Next number is 54. That is x. Clearly x is subset of y. Therefore x union y is equal to y. So I hope that you understand this solution. Let us go for next problem. Dear students, welcome to the 10th problem of this today's session. This problem is from a complex number chapter. The problem is this: a complex number z is said to be unimodular if modulus of z is equal to 1. That means if the modulus of the complex number is 1, then that complex number is called unimodular. Uni means 1. That is the first thing he has given one definition. Very good. Right. If there are two complex numbers are there, that is if z1 and z2 are complex numbers such that z1 minus 2 times z2 upon 2 minus z1 times z2 bar is unimodular. So total this complex number is unimodular and z2 is not unimodular. Then the point z1 lies on is. So here it is given that, so solution is like this. Here z2 is not unimodular. That means modulus of z2 is not equal to 1. Modulus of z2 is not equal to 1. And moreover, if you, one more property, if you know that, the problem will be very easy. What is that property is? Z into z bar. Z into z bar. What is z into z bar? This is equal to modulus of z whole square. Modulus of z whole square. Very easy property, that is z is equal to x plus iy. Z bar is x minus iy. That means if you multiply x square plus y square. x square plus y square is nothing but, here you observe root of x square plus y square, square cancel, x square plus y square is equal to x square. So that property, if you know that property, the problem is very easy. So now coming to this problem. So he is saying this total complex number is unimodular, that is equal to modulus of z1 minus 2z2 by 2 minus z1 z2 bar is equal to 1. This is total, it is a unimodular, that means its modulus is equal to 1. Right, squaring on both sides we will do. So what you will have, z1 minus 2z2 by 2 minus z1 z2 bar whole square is equal to 1. See here, modulus of z square can be written as z1 times z1 bar, z bar. So this is also total, you treat it as a mod z. So this can be written as, so this is a z1 minus 2z2 by 2 minus z1 z2 bar times again z1 minus 2z2 by 2 minus z1 minus z2 whole bar is equal to 1. Okay na? Right. This term will be as it is, z1 minus 2z2 by 2 minus z1 z2 bar. Here you will get z1 bar minus 2 times z2 bar by 2 minus, that means this bar will come for all the terms you will get. So here z1 bar times z2 is equal to 1. z1 bar times here z2 bar whole bar is equal to z2. Okay. So we will multiply the numerator terms and denominators, we will take the cross multiplication, we will get the expression. Okay. So let us continue our solution. Dear students, welcome to the solution of this problem. So you first multiply z1 times z1 bar is equal to modulus of z1 whole square minus, if you multiply these two, 2 times z1 into z2 bar, if you multiply these 2 times, minus 2 times z1 bar z2 bar plus 4 times z2 into z2 bar is equal to modulus of z2 whole square. This is equal to, that means you multiply these two, if you take cross multiplication at a time, what happens? You see here, 2 2s are 4 minus 2 times z1 bar z2, again this is minus 2 times z1 into z2 bar plus, see here z1 into z1 bar, this is given by modulus of z1 whole square, z2 into z2 bar, this is given by modulus of z2 whole square. Okay. So any more cancellations clearly? So these two terms will get cancelled, these two terms also will get cancelled. So on the whole, what remains? So here this is a modulus of z1 whole square plus 4 times modulus of z2 whole square. Take these two terms are also left hand side, minus 4 minus modulus of z1 whole square modulus of z2 whole square is equal to 0. Okay now. So if you observe, you can factorize this. You can factorize this by taking these two terms and these two terms, and the factors will be clearly modulus of z1 minus 4 times modulus of z2 minus z1 minus z2 z1 square modulus of z2 minus 1 whole square is equal to 0. So observe here, if you multiply these two, you will get this factorization. Already in the given problem, it is given that modulus of z2 is not equal to 1. That means modulus of z2 is not equal to 1. That means this cannot be equal to 0. Therefore, only thing is modulus of Z1 whole square minus 4 will become 0. That is equal to modulus of Z1 whole square minus 4 is equal to 0. Modulus of Z1 whole square is equal to 4. Okay now. So, let Z1 is equal to, Z1 is equal to x plus Iy. What is modulus of Z1? Modulus of Z1 is equal to under square root of x square plus y square. Here modulus of Z1 whole square means x square plus y square is equal to 4. So, we got x square plus y square is equal to 4. So, clearly x square plus y square is equal to 4 is a circle with center 0, 0, radius 2. X square plus y square is equal to r square in r plus 2. So, our answer is circle of radius 2. Circle of radius 2 is our right answer. Okay. So, such a easy problem. So, the only thing is to remember is to do this problem is z into z bar is equal to modulus of z whole square. This is the only formula. If you know this, the problem will be completed. So, my dear students, I hope that in the morning session you wrote the exam very well. So, in the next class and tomorrow's class, I will explain, I will try to explain the solutions of today's exam paper. Okay. So, always keep watching my channel. Okay. Thank you very much.